Good evening, everyone. My name is Muhammad Hilman bin Hamidun, matrix number 211967.
Good evening, everyone. My name is Yan Yuan, and my matrix number is 213261.
Hi, everyone. My name is Osvera Villa Justin, and my matrix number is 213192.
Today, we are here to present our topic of presentation, which is contactless body temperature sensor. Now, next slide. Now we start with the introduction.
Okay, for the introduction, actually it can be divided into two sections. The first section is about the background, and the other one is scope of project. So first, I move on the background. So next slide. For the background, first of all, the simulatory device was built in the context of COVID-19 to avoid unnecessary contact and to reduce the choice of infection. The non-contact body temperature sensor device works on a series of Stephen Bolden. According to Stephen Bolden, everyone aims infrared radiation in proportion to their temperature. So this infrared signal is serially analyzed to achieve non-contact temperature measurement. In addition, the instrument can also be used to measure the surface temperature of liquids or objects, such as water temperature or teacup temperature. And next slide. Next slide is about the scope of project. So for temperature measuring equipment, the concept of our project is that the person with a temperature of more than 38 degrees, this is usually considered as a fever. And where a person with a temperature of less than 38 degrees is usually considered as a healthy state. For this temperature machine equipment, we need to use circuit analysis, which is 3811, and digital circuit knowledge, which is 3821. And we also need to use knowledge of microprocessor technology, which is 3841. So what's more, for this equipment, we need to interactive digital, 2 AND gate and 1 OR gate, subary was and 2 LEDs lights, which is LED 1 and LED 2. We also use the 38 degrees as limited. So when the temperature is lower than the 38 degrees, the LED 1 will light up, and when the temperature is higher than 38 degrees, LED 2 will light up. So thank you. This for my this for the introduction.
Next, I will presenting about the system architecture, which is the functional description. So the objective of this project is to monitor the risk of people who is infected with COVID-19. The basic operation of this project is the body temperature was determined by the voltage. The LED 1 will be light up if the temperature is low, which is less than 38 Celsius, and the LED will be dimmer, which is 0 V. The LED 2 will be light up if the temperature is high, which is equal to 38 or more than 38 Celsius, and the LED will become brighter, which is 5 V. The light will not light up if no temperature is detected. Next slide. So this is our simulation of the project. So the interactive here is we will put the input, and the LED is to show the output, which is to show whether the light is up or not. Next slide. And this is the hardware description that we use, which is the Intel Quark X1000 with SMD programming, and EZ Macro 80586 training board, and Olimex ARM USB or CDH with ARM JTAG 2010 adapter, 7.08 and IC 7408 node IC, light emitting diodes LED, and other components. Next slide. And this is our block diagram. We use EEE 38111 electrical circuit analysis law for the input voltage. So for the EEE 3121 digital logic circuit law, we'll detect the temperature based on the voltage 1. We'll detect temperature, 0 means no temperature. So for the EEE 3811, which is the electrical circuit analysis law, will control the brightness of LED, and EEE 3841 microprocessor technology law will control the LED either on and off. Next slide.
Thank you. Now I would like to briefly explain the software flowchart for our contactless body temperature. First, we start the program. Now, for the first time, we move EBP and ESP to clear the debugging. After that, we sub EAX to clear the register. Next, we compare the value AX 0 times 1. After that, we J and E switch on. J and E is jump not equal in order to switch on the program. After that, we move AX, which is to insert the data switch 1 to the register. When sensor is equal to 1 is to compare the value, and if it's true, it will print temperature detected. What temperature is equal or bigger to 38 degrees Celsius is considered to be the condition. After, if it's false, then it will jump equal switch off, and it will move AX DS switch 0, and the sensor will be equal to 0. It will print temperature undetected. We will exit the program by using this command int 0 times 80, where the program will exit and then it will stop. Now, my group would like to briefly explain the source code that we use for our contactless body temperature. Yang Yuan, please start for the line 1 to line 22.
Okay, so first we move the EBP and the ESP, which is for correct debugging, and then stop the EX, which is to clear the register EX, and then for the switch, steps, we know that the function of switch is judgment and selection tool. So CMP AX 0x, which is a compared value of AX with 0x1. And then we have two jump function. First one, switch GE. If the AX is equal to 0x1, it will jump to the switch all function. So when jump to the switch all function, we need to move the AX and fetch data from switch 0, and then store the AX. For this condition, that means we do not detect the temperature. In other words, it's the temperature undetected. So we call the sensor off, and we know the GE and we know the GE is the opposite of GNE. So when we got the G, if not, it will jump to the. So if not, it will jump to the switch on function. So for switch on function, so first we move AX and fetch data from switch 1 so to AX. So the temperature detected. So this condition, that means we have detected the temperature. Then we call the CC on. And next step.
Thank you, Yang Yang. Now I will present line 25 to 49. Next, when the condition is the sensor is off, it will move AX yes sensor 0, meaning it will fetch data from sensor 0 and store to the AX. After that, it will print hex to AX. In other words, it will print the value of the AX. The next line, it will print string temperature detected. This will be the output. It will show the temperature will be undetected. Now we move on to the new line, which is sensor on. When the condition is sensor on, it will move AX sensor 1. It will fetch data from sensor 1 and store to AX. This is a bit of a typo actually. It will print hex to AX, meaning it will print the value of the AX, and it will print string. The value will be temperature detected. This will be the output, temperature detected. Next will be the new line, LED1. If the condition will be LED1 if when it will move AX, the temperature 0, and then it will print hex to AX to print the value of AX, and the output it will the print string LED1 low body temperature. This is to show that when the temperature input is 0, it will show that LED1 will light up and as the output, and low body temperature will be shown. Now for the new line, we sub EAX to clear the value of AX. Now for LED2, we move AX, ES temperature 1. We fetch data from LED2 on. We print hex to AX to print the value of AX, like I explained. Next, we print the string LED2 high body temperature as the output of the program. And then new line, we use this command int 0 times 80 to finally exit the program. Next slide, Osvera.
Next, I will present the source code from line 50 until 64. In section .data, we put input code which is switch 1 DW0x1, switch 0 DW0x0, sensor 1 DW0x1, sensor 0 DW0x0, temperature 0 DW0x0, temperature 1 DW0x1. And for the output code is LED1 on DW0x10, which is the normal, and LED2 on DW0x11, which means fever. The temperature 1 DW0x1 is low, and temperature 0 DW0x0 is high. Oh, and it will produce the output like this. 0 means temperature undetected, and 1 is temperature detected. So for LED1, which is 0 value, which is 10 for low body temperature, and LED2, which is 1, which is high body temperature. Thank you.
Thank you very much. That is all for my group today.